So my presentation will be about Electron-based applications and how they have been abused in targeted attacks. So this is the outline of the presentation. So in the beginning, I'll introduce what the Electron framework is. Then I will show a few examples of a few ways how threat actors have been abusing these applications. And the last section will be about like 3 concrete APT cases which we observed or analyzed in the wild. And conclusion at the end, of course. So for the introduction, so what is the Electron project? So it's like open source project where the developer uses the web-based technologies like HTML, CSS, or JavaScript. They will write the application. They have just one code base. Then they will build the application from one code base, and they will create like 3 different like packages for all 3 major platforms, which they can distribute it to the users or to the customers. Electron project uses Chromium and Node.js, and they use these both projects and kind of like build them into one binary. So the Node.js is kind of like the backend, kind of like server side. It's like JavaScript engine. It uses this NPM Node Package Manager, so it's like very extensible. It has lots of libraries. And for process architecture, it uses, or it is inherited from Chromium. So in the Chromium, you have several different processes. There's usually like one main single process, which is responsible for application entry point, which runs the Node.js environment, which manages application lifecycle, which creates the browser, the application windows, and so on. And there are also like few more renderer processes, and each renderer process is for one browser window. There are also like few more processes, as you can see in the screenshot. Some of them are responsible for rendering the content. There are the renderer processes, GPU process for some hardware accelerations, and also there are some utility processes, for example, for like internet communication and so on. You can see this type parameter like in the command line. Electron framework is very popular. So on their website, they mentioned that more than 500 different applications have been developed and are being developed in this framework. These are examples of the most known ones. For example, GitHub Desktop, some of these communication tools like Skype, WhatsApp, Discord, Teams, Slack, Visual Studio Code, and hundreds and hundreds and hundreds of more. So if you are like developer, what is it like writing like very simple hello world application? So first you need to create at least few like simple files. Package.json, it's kind of like metadata or manifest file, which contains like some basic information about your project, like the name, like the version, some dependencies, author name, and so on. Then there is index.html file, which is like the template of the website, which will be rendered. So here you can see simple hello world application. The third file is the main.js, which is like the entry point of the application. So here you can see that it creates the new window. It specifies the dimensions of the window. Here it loads the previously mentioned template. Then it handles the lifecycle events, like when the window or application is created and when the windows are opened or closed and so on. And the last thing I would mention is something which is called like preload, because the rendered application should run, or rendered website should run with kind of like limited privileges. But in the beginning, before the website is loaded, this kind of piece of code is run with more privileges, with having access to the Node.js API, to operating system, and so on. So the developer just creates all these files, then he has everything in one folder, and now it comes to another stage, which is like packaging and building the project. And for this, you can use tools like Electron Forge or this one, Electron Builder. For the example of Electron Builder, it's very simple. The developer has the source code, then he runs this simple command, npx, which stands for Node Package Execute, Electron-builder, -m for macOS, W for Windows, L for Linux, and then the building process runs. And in this example, you can see that it builds for Darwin platform, which is like macOS, and 2 supported formats are like macOS zip, DMG, Apple Image Disk. Another one is Linux, Snap format, and app image format, Windows platform, and sys installer. So one command, these 5 or 6 different packages. And when the application is distributed and the user runs it, the upper one was run on macOS, the lower one on Windows platform. So basically the result is the same, but it's like a multi-platform desktop application. For us, what is interesting, like if you look at these packages, they are usually like big files, you can just extract them, and inside of these packages, you usually find something which is called ASAR archive. ASAR stands for Atom Shell Archive Format, so it's like kind of like a special format, or kind of simple format, in which all the files or the source codes are concatenated one to another. In the beginning of this file, there is JSON object, which describes all the files which have been used in the project. So there is this files attribute, which is array, which contains always the name of the file, size of the file, and offset of the file. And it goes for all the files like one after another one. So it's like very easy to parse this file. This ASAR archive is usually found in resource directories. So you can see here in zip, DMG, snap, exe. Every time when you extract it, you just see the resources directory, and app.asar archive is found over there. Extracting this is very easy. You can write your own tool or your own script, but you don't have to do it. You can use, if you install Electron framework on your computer, you can use this npx asar extract for extracting the whole folder or all the files, or npx asar extract-file for extracting one particular file. You can use 7-zip plugin so that all the archives can behave like the normal, like zip or 7-zip archive. Or there's also the utility called WinAsar, which allows you to extract files or create your own ASAR archives. So this was like very quick overview of the Electron framework. And now I will talk about few examples like which we have found in the wild, or how the threat actor abuse these applications. So one of the possible way of abuse these applications is exploiting the vulnerabilities. And there have been like very good paper in Black Hat USA 2022, which was called ElectroVault, Pawning Popular Desktop Apps While Uncovering New Attack Surface on Electron. And basically in this presentation, they just talk about, if I should say like simply about like basically 3 like kind of security features. One of them is node integration, which is the ability to access Node.js API from the renderer process. And the renderer process is this process which should have like limited abilities just for security reasons. And this node integration can be enabled or disabled. Then another one is called context isolation. So in the beginning, I mentioned that there is some preload.js script, which is loaded with like more privileges. And again, it should be like isolated from the context of the loaded website or not. And again, this feature can be enabled or disabled. And there's also sandboxing, that the rendered web page can be run in sandbox process. And again, the sandboxing can be enabled or disabled. And sometimes the developers either intentionally or unintentionally disable like some or all of these security features, and it can lead to the problem. So in the paper, then they talk about like several different applications, several different vulnerabilities. But for this presentation, I would only highlight this second one, this CVE 2021-21220. It was the only one which we have seen in the wild, and we will talk more about it in the last section. This is basically the vulnerability which affects Chromium prior to this version, this 89.0. something. 64-bit version of Chromium is affected. An important thing, it works only for non-sandboxed windows. So if sandbox is enabled, this vulnerability is not effective. So source code of exploit for this vulnerability is available on GitHub for a long time. So the threat actor can simply just download it if you wanted to exploit it, see here the shellcode variable, change the payload, and use it. So one possibility or one way of exploiting these applications or abusing these applications was exploiting the vulnerabilities. And the second way, which I would say is like the patching existing applications. And the patching can be done either by previously exploiting the script exploiting the vulnerability and running some patching script. Or in some cases, the threat actors get access to the build environment, and they get access to the hosting servers, and they just modified the applications as they are like published by the developers. So example of this patching of existing applications by scripts, we have seen, for example, these simple scripts in PowerShell, where the application or the script first checks the size of the file. If size is not equal to one of these predefined sizes, then it sets this temporary variable. And if this temporary variable is set, then later it downloads the payload from attacker-controlled domain. So basically in this case, it's new ASAR archive file, and it replaces the original file in the resources directory. So this is one way of patching. And another one are the scripts which search for some strings within the ASAR archive and replace them with something else. So here in this, so this is the original. These are the original strings which are searched for by the script, and these are the patched version to which they are replaced. And you can see that in this example, for example, auto updater first is activated, and in the patched version, it's commented out. Or here there is the URL address, which is the legitimate one, and after patching, there is the malicious one. So these are just two examples. Now I will talk about three different APT cases, which I have helped to research, like in the past. So these are the Iron Tiger and the application which was called Mimi security chat application. Then one more actor, which we don't give him like special name, but this actor was responsible for abusing these COM and live help custom engagement applications. And the third actor we call WaterLabu, and the application they abused was called Meitia live chat. So let's go for this Mimi security chat application. So it's like multi-platform chat application. Its name Mimi comes from this word in Chinese, which Mimi means secret. And this is the website of the application from which all the versions have been downloaded. So they support macOS version and Windows version. Both of them are written in Electron application, in Electron framework, and both of them have been trojanized for some time. There are also Android and iPhone applications, but we haven't found anything malicious during the time of our research. So for researchers or for reverse engineers, we first locate the app.asar archive, as I mentioned before. And in this archive, we can notice this file, which is called electron-main.js. And when we look into this JavaScript file, we can notice this kind of suspicious obfuscated piece of code starting with eval function packed, which is the signature of this Dean Edwards JavaScript packer. This packer, it has online tool, it's very simple to use it. Anyone can just go online, find this tool, paste some code which he wants to obfuscate, click pack, it gets packed, and now this code does the same function as the previous function, but it's like more hidden, more obfuscated. So when we do the obfuscation of the previously shown code, we got something like that. There is hard-coded IP address, checking platform, in this case Win32, and it downloads like three different files. One executable, which is signed with DLL sideloading vulnerability, DLL file, which is loader and decryptor, and binary file, which contains the final payload. In this case, the payload was Hyperbro, which is like one custom backdoor of Iron Tiger threat actor. For macOS version, it's kind of similar. Again, checking platform for Darwin, which is macOS, hard-coded IP address. One file gets downloaded. By chmod plus x, the file is made executable, and it's executed at the end. During the research, we noticed like something interesting, because one day we downloaded the file or the archive from the application developer. Is the picture on the left, and we didn't find anything malicious there. So we tried again a few hours later, and there have been like few small changes. This electron-main.js had a different modification time, and also it had different size. So it seems like the attacker was monitoring, like when the developers published new version, and when it happened a few hours later, the attacker just modified it, and they were like spreading the malicious version. Interesting thing is that these applications in these MimiChat versions were not signed and the developer was unverified. So under Windows version, it displayed like one security warning. So if the victim ignores the warning, they get infected. Under macOS, there was like one warning in Safari browser. Victim needs to click allow, but then it doesn't allow to open the file because the developer is unverified. So the victim needs to go to the system preferences, security and privacy tab, allow running the file. After that, the open button appears, and after that, the victim gets infected. But still, people get infected, ignore all the warnings, and this is what happens. The last slide for this Mimi secure chat application is like one interesting script we just found in our telemetry. So basically there was a malicious domain and we found get request to file script.js. And script.js was a custom JavaScript password grabber. And this subdomain.domain, this server in the middle, was some authentication portal for the development tool. So the developer connects to the authentication portal. This authentication portal was likely this script, this JavaScript password grabber was injected into it. So during the logging process, the credentials get exfiltrated, and then threat actor can probably have access to the build environment and modify the application. Second application which I will mention, or second case, are these Com and Live Help customer engagement platforms. So what are these platforms? So imagine that you are like the operator of few websites and you use this kind of like console applications on the left. This is the application written in Electron framework. Then you have several websites, and on each of these websites you embed this kind of widget. And when the visitor of the website clicks on the widget and registers, puts their name and so on, then this kind of communication window appears. So the customer can use this window to communicate with you, and you are using this agent console application for the communication with your customers. So this agent console application has been trojanized in this case. So this happened like in the end of last year. There have been like some blog posts and activities, let's say in the end of October 2022. When looking into our telemetry, we noticed like some hints going even back to February 2022. So it seems that something was wrong for maybe half a year until the attack was observed and noticed by researchers and also the customers and the company. So short, like small schematics, like how all the attack works. So there is this trojanized Electron application. It was the application on the left I mentioned in the previous slide. Then this application loads this JavaScript backdoor, which then drops legitimate signed executable file, which sideloads DLL decryptor, which decrypts and loads the first stage of the malware, which downloads and loads the second stage of the malware, which downloads and runs some or all of these modules. The modules can be SOX proxy, Skype stealer, Telegram stealer, general information stealer, tool for taking screenshots. It can download zip packages with the update package with the new versions. So there are like many things which can happen. If you are reverse engineering or analyzing this application, so you just unpack or this installer. So you can see here app.asar archive, and there is file called main.js. And at the end of the main file main.js, you can notice this piece of code, and there is some long hexadecimal string. So you beautify the code. There is this string. Below the string, there is some XOR encryption. Here, HTTP GET. So something gets downloaded from somewhere, and by eval, it gets executed. So this is the long hexadecimal string, XOR key, decryption, and it reveals the URL address. So when trying to download the content from URL addresses, you can find there like several stages of JavaScript code. So this piece of code is the collection of operating system information. So it computes the fingerprint, gets list of the tasks, gets computer name and username. Another script can run, for example, command line commands So here you can see cmd.exe. So it creates like, it runs the shell commands on the infected machine. This was the one stage. Another stage is the code which is responsible for maybe trojanizing or modifying the original applications if necessary, or dropping additional stages of the malware. So if you look in the code and make it a little bit bigger, so we can notice something like hexadecimal string starting with 4D5A90, which looks like MZ marker of executable or DLL file. So again, executable file, DLL file, binary file. The third case I will mention is this Metia live chat application. So this is kind of a similar type of application as in the previous case. So again, you have this button on the website, so the customer can chat with you through this chat window. And this chat application, which was like exploited or trojanized, was the application which is run by the website operator. So this is kind of like interesting way how we found this application, or how we found this situation, or how we discovered these samples, because at some time, we were analyzing one campaign which was responsible for stealing cryptocurrencies, and this campaign connected to one online code repository, and on this repository had open directory, so we were able to download like many different files and scripts. We could analyze them, and these files refer to this Metia application. And one of these files which we analyzed looked like this. So this is HTML file with just title called Metia, which is the name of the application. Then there is the content of the script. Then this application displays some pictures, which I will show on the next slide. It also updates some statistics. You can notice here that there is the domain, but name of the application has letter I, but here is letter L. So this is like the typo-squatting domain. And the code of this script is just running the exploit for CVE 2021-21220 vulnerability. So what is displayed like when you run or when you open this HTML file in your browser? So it downloads the picture, and there is the picture, or it's the screenshot of some withdrawal or confirmation of some cryptocurrency transfers. So when the target or the victim opens the file, he's displayed this screenshot, but in the background, it runs, or this HTML file runs the JavaScript with exploit. Because older version of this Metia application had some were vulnerable, because they have been created with older version of Electron.js, so there was no sandboxing, so all the content was rendered inside of the application, which was later noticed by the developers, and they put there this comment, which says, for security reasons, all the links are opened through external browsers. So this was the main thing why this vulnerability have been successful in the past, or exploiting this vulnerability was successful in the past, because the Electron application disabled or didn't enable the sandboxing. So if I show this kind of schematics, so you have this targeted application, and threat actor sends the malicious link via this chat window. And then the application, when operator clicks on the link, it connects to the code repository, and from this code repository, it loads the exploit. The exploit is executed and runs the shell code. The shell code is the Cobalt Strike, which then runs several different batch commands. And some of these batch commands or PowerShell commands can patch the Electron application, and the patched Electron applications then later downloads additional JavaScript payloads and runs them. So I showed in the beginning, there are different scripts. Some of them can replace the app.asar archive, some of them can just patch it. For us, it's important that inside of this app.asar archive, again, there is the file called create-window.js. And when we look into this file, we can notice like several modifications. One of them is the application URL. So instead of Meichia something, there is some suspiciously looking URL address. There is also like event on creation of new window, execution of JavaScript scripts. And you can see that there is like kind of piece of JavaScript code, and inside you can notice like kind of like again suspicious domains which contain some payloads which are then downloaded and executed within the context of the application. In this repository we have found like many other scripts, and one more which I would mention here is this script for grabbing credentials and stealing cookies. So the script, when it runs within the application, it checks what is the title of the loaded page. If the title, this in Chinese means login, denglu, which is login. So if it is within the login page, then it searches for email and password text boxes. And if they are found, their value is put into the username and password values, and later it's exfiltrated to the domain, which is controlled by the threat actor. And the same thing is done for cookies. So again, by document.cookie, the cookies are just taken and again exfiltrated by this command. So for the conclusion, or for the takeaways, I would say that the Electron applications are usually quite big projects. So you download the file, it has hundreds of megabytes, and you can just extract all the files. It can have maybe hundreds files. There is app.asar archive, which I mentioned before. It can have, again, like hundreds of different files. So it's like a good idea to have a little bit understanding like what kind of files are there, maybe where to look for some modifications, where to look for some patches, because it can, when you see it for the first time, maybe it can take you quite a little bit more time just to understand like where to look for some changes, so some malicious changes. Then in these cases, some of these attacks were like supply chain attacks. So they're like very successful to defeat the users, because when the person downloads the application from the official website, they don't expect it will be malicious. So they just download it. Even if it shows some warnings, people think, oh, it's a legitimate website, let's allow everything, ignore all the warnings, let's go. And then how some victims got infected. All the actors I mentioned, they are, I would say, quite advanced actors. They have like strong technical capabilities. They patch the Electron applications, but they patch it for the purpose of downloading additional malware, because for the threat actor, the most important is to have the native malware, which is like more capable, more strong than just running some JavaScript. So Electron applications are just like one stage, or the first stage, but the main stage are these additional or custom native malware. In some cases, the malware is just custom, so this kind of like helps us to guess the attribution of the threat actor. Motivations of the first two actors is just the espionage, just downloading, stealing the files. The last actor was interesting in the financial gain and getting the money. So I would also mention, like, this is the last slide, that we have published like 3 different blog posts where it's like much more information, which I couldn't fit into like 30-minute short presentation. So if you would like to know more details, or if you are interested more about these topics, so please have a look at one or all of these blog posts where you can find more information. And that's all from me, so thank you for your attention.